Hello, in this video we are going to learn how to solve cubic equations. More specifically, we're going to use division while solving these. The reason I state that is because in the next video we'll do the same two questions, I'll just use a slightly different method. There'll be some similarities, but the main way we solve it will be different. This one will look a lot like long division you learned in primary school. Before we start, let me just remind you what we did in the last video. We just looked at some of the shapes of these equations. When we have a positive number at the start, the shape often looks something like this. And it doesn't have to look like that, of course. It could, the humps could be in different places. We could even get although none of these will be this case, we could even get to where the hump is so close together, so squashed, they're the same. The two humps become one, really, one flat line. We won't be looking at a question like that, so don't worry too much about it. Well, in this class we won't. In fact, both of these will look something like this one here. What's important to note is there's three answers, three roots to the question. X equals three different things. So we're going to get fx equals 0, and we're going to get three answers for x. They're the three roots for x. That means it also has three factors. Something like x plus something. Let's put in a little box. I don't want to use letters because I'm going to use letters later on in the video. X plus something. We're also going to get three factors of these equations. Now, these are actually quite difficult to do when it's just a random, completely random number. But luckily for you, these aren't completely random numbers. I've picked beginner questions. In beginner questions, one of these answers is usually quite easy. In fact, all of these answers here are actually quite easy. But that's fairly important because to solve these questions, we actually are required one of the answers first. We need to have one of the answers to help us get the others. Now, so much so, in exams and in questions you see in books, they will often give you one of these three answers. They might tell you it in some interesting way. They might draw you a picture and say it crosses the x-axis at x equals 7. They might tell you that. That's enough information to start you on the question. It might tell you one of the roots is 7. It might tell you one of the factors is x minus 7. This is some of the ways they start you off on questions. Other things they do is require you to guess your first answer. And I know that seems horrible, the fact that you're guessing, that shouldn't be taught in maths classes usually. But that's how it works. In fact, when we get to more difficult cubic questions later on in the course, when we have more tools, including calculus and a few other ideas, one of the ways we solve these, the way most computers would solve a cubic question, if you were doing science and engineering, economics, how you would solve a cubic would be simply by guessing an answer and then doing a few tricks that we learn to make it better and better each time. So it's not too bad. Guessing has a place in maths, so don't worry too much about that. But in this case, we're still going to be a little more exact, but we will have to guess our first answer. So I'll jump into this and I'll start part 1. So part 1, let me write this out again, I guess. 5x plus 6 equals 0. Okay, so I'd like to guess one of these answers. But let me draw out the factors again. I'd like to guess one of these numbers. One of these numbers that are here with the x. But I'd like to point out something to you. How do we get to the 6? If three numbers multiply to get 6, and I'm promising you one of those numbers are nice and easy. Because of course, lots of numbers multiply to get 6. Like they could be 3.4, let's see, 3.4 could be minus 7.2, and that would make the last number minus 4.08. So of course they could be any three numbers, but I have promised that one of them is going to be a nice easy integer. And often the exam will say something along those lines, that all answers are integers, or at least one answer is a positive integer, maybe a negative integer, doesn't really matter. But my point is that these three numbers here will multiply to get 6. And since we're promised one of them is nice and easy, that means all I need to know is the factors of 6. And the factors of 6 are, well, 1, 2, 3, and 6. But let's not forget, what about minus 1? What about minus 2? What about minus 6? All of them are the nice integer factors of 6. So by, usually what's written in the exam, but by what I'm telling you is, I'm promising you one of these answers will be correct. Actually, I've given fairly simple questions because I constructed them myself. So actually all of the answers are written right here somewhere, if you want to go through the trouble of finding them all. But we don't want to go through that trouble. What we would like to do is just test these answers until we find one. Once we find one, we have a very solid way to find the others. I don't know if it's faster than just checking them all. It's probably not in this case. But like I said, it's not always guaranteed that all three numbers will be nice and pretty. One of them will be pretty in my questions though, and in most questions you do in exams at this level. Okay, so really, if these are the factors of 6, any of these numbers could be here. The roots are the same, because remember the root is just minus the factor. If the factor is x minus 2, the root is 2. X equals 2. So really the roots are just the possible roots, the possible roots of this are just the same here. So instead of minus 1, it's plus 1. Instead of plus 1, it's minus 1. So let's just test some of them out. Let's just put some of them in here. Let's say fx. Actually, let's write that here. Let's write fx equals this. Let's test some ones. Let's test f1. What does that equal? And so we just put 1 in. 1 times 1 times 1 is 1. 1 times 1 times 2 is 2. 1 minus 2. So we're at minus 1. 1 times 5 is 5. Minus 1 minus 5 is minus 6. Actually, let me write all this out because I can see it's the right answer now. And we would get 1, we would get minus 2, we would get minus 5, and we'd get plus 6. And does it equal 0? It does. Okay, perfect. And this is what I do to start a question. I would do as many of these as I needed to do until I got to this answer. But of course I got lucky and it was the very first one. So this is one of the answers basically. This is x equals 1. That's one of the three answers. And as the title says, we're solving this thing. We're trying to find what x equals. So we're already finished one of the answers. But I'd just like to point out that means one of the factors is x minus 1. One of the factors of this is x minus 1. And we're going to use that with division to actually answer this question. So how we're going to do that, let me see. We'll write these factors again, except these, let's pretend they were multiplied together. And they were multiplied together into a quadratic. Because that's what we'd get if we multiply two of these brackets. We'd get something like this. I don't know what any of these letters are. We'd get something like this. And this is equal to this entire thing. I won't write it again, I'll run out of room. That's equal to that entire thing. So what we have here is two numbers multiplied to get this. So maybe I shouldn't say numbers. Two expressions multiplied to get this. Well, that means if we just divide both sides by x minus 1, we would simply get is equal to this here. Ax squared plus bx plus c. And this is a quadratic expression, and we are able to solve them. We are actually able to solve them. And remember, if these both multiply to get 0, then one of them, we know this one, we dealt with the possibility this one is 0. So we just put this one equal to 0 and we could solve that. But we'd have to find what it looks like first. So we'll actually just do this, what this suggests. We are just going to divide this fx, this entire thing, divided by x minus 1. Let me rub this out so I make sure I have room. So I'm going to use old style long division to do that. This divided into x cubed minus 2x squared minus 5x plus 6. So we're going to divide in like we did since we were children, divided in. Maybe it'll look a bit different. To be honest, I don't remember too well how I did long division because I don't teach it, I don't use it. So I apologies for that. But it's how I roughly remember it, at least. I look at this and I ask myself, how does this divide into here? And I'll just do it in steps. So I think to myself, what would I have to multiply by this? Because that's what dividing in is. Let's go 6 to 2 divided into 6 is what would I have to multiply this to get this? Well, the answer is 3, isn't it? So what would I have to multiply this to get this? But let's do it in steps. We will only look at the very first guy. And the very first one over here. What would I have to multiply this by to get this? Well, the answer it'll have to be x squared. The answer will have to have an x squared. So let's multiply x squared by this guy out here. We will get x cubed. X squared by that is minus x squared. So we've actually found the correct first term here, but the second one isn't the best. So let's go ahead and take this away from here and see if we can get all the rest of these numbers out. Basically what I'm saying is I found the x cubed, but I haven't quite found enough x squares. I found one of them, or minus one of them, but I haven't quite found enough. So let's go ahead and take this away from here. So let's take it away. We'll take minus there. If I'm changing this to a minus, I better change this guy to a plus. So let's say they cancel, and we get minus 2x squared plus x squared. We get minus x squared. And let's bring down one of the next terms. Let's bring down 5x, because we're going to find a term there that will do the same. And we're just going to do this until we get to 0. Until we get them all, or hopefully get them all. Okay, so now I ask myself, what do I need to multiply this by to get this? Well, I'll have to multiply it by minus, and I'll have to multiply it by x. So let's go ahead and multiply minus x by this. The first one, we get what we hopefully should have got. Minus x by minus 1 becomes plus x. Okay, close, but still not close enough. And we're exactly right in this part, but we're still missing some of the x's and indeed 6's. We could add the 6's down here if we want. It would just get in a bit of a mess, so we don't bother. So we're just short some of the numbers. Let's go ahead and take this away. Take away minus x squared, it becomes a plus. If I change the sign, I better change both. So this one cancels. We get minus 5 minus 1x. We get minus 6x. And let's add on the next 6. Okay, what do I need to multiply this by to get this? We have an x already. We need to multiply by 6, and we need to multiply by a minus 6. And thankfully this goes in evenly, because I picked the question, so I knew it would. Let's see, minus 6 by this is minus 6x. Minus 6 by 1 is plus 6. This time we've actually got it all. We don't need to, we can take this away, but it will just cancel nice and quickly. And there's no more terms left. We've divided it in evenly. So if this divides into this evenly, that means x minus 1 multiplied by x squared minus x minus 6 is equal to fx. Now remember, I've made up fx. fx doesn't exist. It's just this function here. But I do know it's equal to 0. So let me just go ahead and put a 0 in there. This now is equal to 0. One of them we already knew. We already knew x minus 1 was equal to 0. We already knew x was equal to 1. But now we've got the new knowledge of x squared minus x minus 6 being equal to 0. That's good because we know how to solve quadratics. Let's solve it up here. I'll write nice and big. X squared minus x minus 6 equals 0. We just need to find the factors of this one. Now, luckily for us, the factors of this question are not as... factorizing a quadratic is not as difficult as a cubic. We've learned how to do this. We first look for a simple answer. Is there two numbers that multiply to get 6 and add or take away to get minus 1? Minus 6 and add or take away to get minus 1? Yes, there is. There'd be 3 and 2 seems to work. If I make 3 minus and 2 plus, that will work. We will get minus 6 and we will get minus 3x plus 2x. We'll get minus 1x. So that means two answers here. X plus 2 is equal 0. X is equal minus 2. X minus 3 is equal 0. X is equal to 3. That's our answer. That's our three answers. Minus 2, 3, and the one we first guessed, 1. And that's how we do a cubic. Last thing we should check is we should check the answers. If we put 1 in, we already know 1 works. We should put in minus 2. We would get minus 8, minus 8 plus 10. So what's that? Minus 16 plus 10 is minus 6 plus 6 equals 0. Perfect. Let's put in 3 and check. We get 27 minus 18 is 9. We get minus 15, which is minus 6, and plus 6 is in fact 0. Okay, so that is an answer. Now, I'm sorry, I've miscalculated how long I would go. So we will not get to part 2. So I'll leave this for homework. If you're doing the video, try out part 2. The only trick I'll point out is make it equal 0 first. Rearrange it. Put everything, destroy everything on the left, have everything on the right, and solve that question. Should do a very similar way. Look for the factors of the constant number. In this case, the constant number will be minus 5. It's actually a little easier. The only factors of minus 5 are 1, minus 1, 5, and minus 5. So give that a go. Put in the comments below. Ask me any questions about this. It's a complicated one. You'll probably need to see this done again. If not, brilliant. But if you do, ask me in the comments and we'll put up another video. Thanks for watching. Have a good day. Bye.